problem. We have one more problem, which is problem 3. Problem 3 on quantum mechanics. Okay, so for this problem, the setup that we are given is that we're given a bunch of particles. You're given n particles, an even number of particles, up to 2 times 10 to the 5 particles. And it's even. Yeah, particle, 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 particle. They're all going to be at positions pi, like speed si. And what happens is initially, they're going to be like moving like this way. They're going to be moving like this way at the very beginning. So the kind of like every even one's going to be, every odd one is going to be moving to the right. Every even one's going to be moving to the left. That's the initial configuration. Now what happens is we're going to have some observations. And the way observations work is that we make our first observation 1 second after the beginning, and then make our second observation 2 seconds after the first observation, and then make our next observation 3 seconds after the previous operation. So basically, at each observation t happens t seconds after observation t minus 1. That's the rule that we will be following for when these observations happen. And when these observations happen, upon observing, all the particles will switch their direction. So the moment we observe them, they will all flip their direction. And then we observe it again, they'll flip back. And now we want to find out, basically when two particles collide, they will destroy each other. And so now the question is, basically we want to figure out for each particle, what observation does it disappear, at what observation number does it disappear on? So we basically simulate forever until all the particles have eventually collided and disappeared. And we can prove that is always possible. Okay, so how can we approach this problem? Well, let's first not worry about this observation and flipping directions thing. There was no observation, and there was no flipping directions, and we simply want to figure out for each particle when it collides, how do we calculate that? Well, the particles are going to be colliding like in these pairs, right? Like this pair is going to collide with each other, this pair is going to collide with each other, this pair is going to collide with each other, so on and so forth. There's no way for this particle to collide with this particle without skipping over this particle. So it's going to be like the adjacent pairs will be the ones that are at risk of colliding. And we say that if the two particles are at positions, let's see, they're at positions P1 and P2, and they're moving at speeds S1 and S2, then we can do the math. The number of seconds it will take to collide should just be the distance between them divided by the speed, the total speed, right? So it should be P2 minus P1 divided by S1 plus S2. That should give us the total number of seconds that it takes, which is not necessarily an integer, but just the number of seconds it will take for these two particles to collide. Now, this observation thing and flipping directions kind of messes things up, right? Because like when you observe, they start switching directions, they start moving the other way. But the trick to observe is that like these observations don't just happen at random time intervals. They happen at a very specific like cadence. The first one happens in 1 second. The second one happens 2 seconds after. The third one happens 3 seconds after. And observation t always happens t seconds after observation t minus 1. Well, how is that significant? Well, first we observe that when we flip all the directions, now it's like this pair is at risk of colliding, this pair is at risk of colliding, this pair is at risk of colliding, and these two on the ends will never collide with like anything. Right, so we can similarly calculate like for these adjacent pairs, if there was no flipping direction, how much time would it take for them to collide? And now here's the trick. Let's say on a certain observation, after a certain observation, let's look at this pair. Let's say after X observation T, the particles have reached like here and here, but they have not collided yet. Now, on the next observation, we spend t plus 1 seconds going the other way. And so in the first t seconds, we will basically reverse all the progress that we made on the other pair. And on the last, we'll basically reverse all the progress that we made. And then on the last second before the observation, we'll make one new second of progress on the other pair. And so that's the trick. The trick is that when we flip the observations, all that's happening effectively is that we reverse all the progress we made on the previous like time segment, and we make one new second of progress on our current adjacent pair. And so basically, on every like odd observation, we're making 1 second of progress on these pairs. On every even observation, we're making 1 second of progress on these pairs. That is all that is happening. And so once we understand this, it becomes a lot more practical to design an algorithm for this, because now we can just basically take all these adjacent pairs and insert them into a priority queue sorted by the time it will take for them to collide. And then we'll basically simulate basically if a observation or if a pair is going to collide in like X seconds, then we actually need like 2X observations, because like they only make 1 second of progress like every other observation, except for like some parity differences. But basically we can just throw all into a priority queue and figure out like the earliest, the observation time at which they will collide. We can calculate that now. And then let's say we have a priority queue of all these. We have a priority queue of the pairs by when they collide. And then the final step of the puzzle is that when these two pairs collide, we remove this pair, but now we introduce one new adjacent pair, which is between this one and this one. So basically the ones that are on the two ends of the original pair are now a new adjacent pair that could possibly collide. And so we need to insert that into the priority queue along with when that would collide. And that's it. That's actually the entire problem. So to finish this off, we simulate with the priority queue. The priority queue should take no more than n log n time, because each time we pop something from a priority queue, we are deleting 2 particles. So after n over 2 steps, we are done. And the priority queue stuff takes log n time, because there are at most O of n adjacent pairs at any point. So this is the n log n solution. All right. Any questions on the third problem? Okay. Then yes, those are all 3 problems. I guess I'll turn it back now. Let me stop my screen share. Or wait, I'm unable to.
Yeah, sure. Thanks, Max. And
Yeah.
anyone can leave any message to our coach, Max, and I will share the screen with you about our USACO report feature from SCAM. From this season, we launched a new feature about USACO report card. When you visit our website and click the USACO report, so this is our text-based solution from our teaching team, and we will give you an estimate score based on your test case you submit. Okay, I will try
Can you just try to share screen? I can't stop my screen share for some reason.
Okay, sure. No
Yeah, so
problem.
can you just attempt to share?
Yeah, because there's some technical issues, so that's why the Go level cannot be live. So we will upload the video as soon as possible after we finish. Thank you. Yeah, you can try to click the usable report and see the text from our teaching team, the analytic report. Yeah. Any question? Yeah, feel free to ask. We can keep 10 more minutes here. Just click the right button here. And then you will see. Oh,
Yeah. Are you able to share? Because the stop share button just doesn't do anything for me.
just like the test case you
Okay.
passed. Yeah, any question? right, guys. Last but not least, we still provide one-on-one consultation with our coach. So gold level and platinum level with our coach. If you are non-SCAM student, feel free to submit your request from our website. Thank you all for coming. Have a good night.